Chapter 10, Question 1. This is deals with the definition of what money is. So, Part A, this is cash is a widely accepted means of payment, so therefore that's considered money. Part B, no, because old Bob Bob Dylan records, not everyone owns it, and not everyone. It's not a common accepted means of. It is a means of transaction, but it's not common. It's not a payment method. Part C, this is true. This is a common method. E-transfer and anything transferring with banks and checking accounts is a widely used form of payment. Part C, no, because not all people have or need auto dealing detailing services. Part D, no, because this is not a widely accepted means of payment. Part E, no, because this is an old currency and the currency doesn't exist with every person. It's not common. Question 2, this is definitions. A monetary base is your total amount of currency that is in the general circulation in the hands in the public and the commercial banks deposits, which are held in the central bank reserves. M1 is your currency plus your checkable deposits, and M2 is the M1 plus the saving deposits, money market, mutual funds, and other small time deposits. Question 3. So, what is a money multiplier? Money multiplier is 1 over the reserve ratio. The reserve ratio is 10%, which is 0.1, and 1 over 0.1 is 10. Therefore, money multiplier is 10. Part B, this would increase the Part B, the banks will have a higher reserve ratio because the banks will want to keep more money in the reserves for more people who are coming to the ATMs. Hence, since the money multiplier is inverse to the reserve ratio, a higher reserve ratio will lower the money multiplier. Therefore, a higher reserve ratio and a lower money multiplier.
So question 4, the answer is the Federal Reserve would decrease interest rates and increase the money supply by buying federal bonds. Now, why is this? So if the Federal Reserve is buying federal bonds from banks, that means they're giving an influx of cash to banks. This would allow banks to lend more money at high money multipliers. This would encourage individuals to apply for loans or deposit wealth. This would generally just increase the supply of money going out into the economy. Question 5. So example 1, the reserve ratio was, I think, 5%. And so the change in reserves was around $10 billion. And the money multiplier, if the reserve ratio is 5%, the money multiplier would be the reciprocal of that. So 1 over 20 is a 5% reserve ratio. So the money multiplier would be 20. So then the change in money supply, which is the money multiplier times the change in reserves, would be $200 billion. Part B, the reserve ratio is 20%, so the change in reserves is $1,000, and the money multiplier is 5. Again, this is a reciprocal of 20%. And so the change in money supply is, again, money multiplier times the change in reserves, 5 times 1,000, which equals $5,000. Now, Part C is related to Part 1, but there's some big differences. So in Part C, the reserve ratio is 100%. The reserve ratio is the ratio between the amount of deposits coming in and the amount of cash that banks are keeping in reserve. So for every $1 in deposits and loans, there's $1 the bank is just keeping. So essentially, it's a state of equilibrium. The change in reserves is the same as in Part A, $10 billion. However, the money multiplier, again, is different than the money multiplier in Part 1. The money multiplier is only 1, essentially reciprocal of the ratio of 1 to 1. So thus, the change in the money supply, 1 times the change in reserves, is only $10 billion. So this is a crazy decrease from example 1, where the money multiplier is 20. And this will play out later in question 6. So question 6, and the answer is, so the answer part A, the money multiplier is equal to the reciprocal of the reserve ratio. So like we went over it in question 5, part C, the money multiplier would be equal to 1 because it's the reciprocal of the reserve ratio 1 to 1. Part B, if the reserve ratio was 100%, this would reveal banks' inhibitions about lending. Essentially, banks would be maintaining a level of equilibrium between reserves and deposits, and this would usually be due to fears of insolvency, but in this case, this is due to government regulation. So this demand to deposit will decrease, and thus interest rates will rise, and we know this based off the inverse relationship between demand and interest rates. In Part C, finally, consumers would definitely be more likely to invest in other financial intermediaries because high reserve ratios would allow for no monetary growth. So essentially, if I deposited my money in a bank, there would be no really growth. It would just be static. It would just be one-to-one. If there is a low reserve ratio and say, like in problem A, and a high money multiplier of 20, for every $1 I'm depositing, the bank is lending out $20. So this is an incredible growth of money to the economy. It would make more sense for consumers to invest straight into other ventures like companies or bonds or the market. Why? And they should do this without the aid of the bank. And you might ask why. It's because they don't really need the bank in this scenario. Essentially, the bank doesn't really add anything to them. There's no really need to take a loan out if you basically already have the money that the loan would be giving you. So this is not a good option. 100% reserve ratio is not as good as we can see. It might be good if the Federal Reserve is wanting to decrease economic growth, like if there's a bubble that might pop, but usually if the economy is wanting to grow, this would not be a good scenario. So thank you, and I look forward to seeing you guys again. All right.
So question 7 says the Virginia Community Bank has $2 million of extra cash sitting in its account, and it gets a call from Bank of America asking to borrow it for 24 hours. So if the annual interest rate on federal funds is 4%, the one-day interest rate on those federal funds is that 4% divided by 365 days, so 0.01% roughly. So how many dollars of interest will Virginia Community Bank earn for lending this money for one day? So it is the $2 million times this interest rate for one day, which turns out to be about $219.18. So if the Virginia Community Bank lent this amount every day at the same rate for an entire year, it would earn about $80,000 of interest, multiplied that one day earnings by 365. So question 8 says, after a meeting, the Federal Reserve's Open Market Committee votes to cut interest rates from 2% to 1.5%, and they will make this happen by increasing the supply of reserves. So as a result, will banks usually lend more money in response or less? They will lend less money because they need to keep it in the reserves, and this will tend to lower the nation's money supply. And part C asks, will this typically increase aggregate demand or lower it? And it will increase. Question 9 asks to use a Fed economic database to graph the effective federal funds rate from 2007 to present. So the federal funds rate in 2007 was about 5.3%, and the rate around the first week of January 2009 was about 0.1%.
With question number 10, where we get to watch money being made in action through a bank, in parts A and B, the monetary base is 100 and the M1 is 100. In part C, the monetary base is 100, but the M1 is 150. And the action that creates this money is Max's request for a loan for 50 of their monetary currency. In question 11, part A, the banks would demand more reserves as there's now an incentive thanks to the interest that the Fed pays. And in part B, the banks are going to make fewer loans because it's significantly easier for them, if the interest is good enough, to just leave the money in reserves with the Fed instead of hunting and finding good customers to loan out funds to, which leads to a decrease. In part C, this increase will increase the demand for reserves, and that leads to an increase in the reserve ratio and then a decrease in the money supply. In order to fix this with part D, the bank would have to increase the supply of reserves with the help of open market purchases.